think everybody was during the first presentation, so let me introduce again myself. My name is Jacek Kralikowski, and I'm going to talk today about working with surface mount components. Why? Because it's fun. And why this presentation? Because many people think it's impossible to work at home. That this is very complicated technology, that you need very complicated equipment, expensive equipment to work with. That's not true. You can have all equipment that you need will fit under your desk. So you don't need anything special. Well, you need some special tools, but it's not a rocket science. Another misconception is that it's expensive. Well, yes and no. Those tools can be expensive. You can spend many thousands of dollars on those tools. However, embrace eBay. Really, you can buy lots of very good tools for cheap, for peanuts. For example, many of those tools that I use, that I will show today, I bought for $15, $20 because either someone didn't know what they were selling, or it was just cheap, and I was just lucky. For example, this great soldering station pays. I wouldn't change it for anything else. I paid $50 shipped. You can find it. So, a few words about me. My day job is as a senior researcher at George Mason University. Nothing related to ham radio, nothing related to electronics, nothing related to what I'm going to talk about today, because I work at geography department, geography and geoinformation science, and I'm doing programming there. I'm also a PhD student at the department, and the name of my program is Air Systems and Geoinformation Science. Again, nothing related to the topics that I'm going to talk about. I graduated with a computer science degree from Warsaw University of Technology, and this actually wasn't a bit related to electronics because it was at computer science program at electronics department at the university. I have always been interested in building, designing electronic circuits, so at heart I'm an electrical engineer, even though during the day I do computer programming. And since the last presentation I got licensed. So what am I gonna talk today? I will talk, the general topic is working with SMD components at home. What you can do, and how to do it. I will tell how to handle them, how to solder, how to handle the boards. I will give few tips about PCB design for SMD, because there are some tricks that you should know. However, this will not be a class in PCB design. You should know it if you want to design something for SMD components. I will not talk about design for manufacture. This class is about working at home. And I will not. So, how to solder those tiny parts? If you ask just anybody, they will tell you, okay, take a soldering iron with very thin tip, very thin solder, and you're set. No, don't do it. This way, you're just going to waste a lot of time and discourage yourself from working with SMD devices. So this technique is just an extension of the technique you use for through-hole components. SMD components require completely different technology. Yes, I'm repeating myself. There's one technique that I'm going to talk today, which is very efficient, very easy, and this is reflow soldering. Unfortunately, I said that it doesn't, SMD technology at home doesn't require much of investment. Unfortunately, you may have to invest a little bit of money. But as I said, if you're frugal, you can do it on very cheap. If you want to start, one thing that you should have is a good temperature controlled soldering iron, and you should have it anyway for through-hole work. And another tool that I really recommend getting is hot air station. This is maybe something similar to this. So you have knobs where you can control airflow and temperature of the air. This is the nozzle. The hot air comes from here, and you hold it and you blow hot air. This is light, very easy to use. Don't use hot air paint strippers. It's gonna ruin your circuit. So what should you do to start working with SMDs? Two things: stop fearing it and start working. That's it. Simple. What about details? Well, that's where the love is. Through-hole components, I actually found through-hole SMD components much more convenient than through-hole components. You can, first of all, you can design smaller board. You don't have holes which takes space on the board. You don't have pads which take space on both sides on the board. And if you make the boards yourself, you don't have to make drill holes. And this is actually one of the things that's, not that I had problems with it, but was very annoying. When I make a board for SMD, I just make it, and sometimes I don't have to drill. I don't have to touch the drill because I don't have to drill on the holes. You can, well, PCBs in general, you can order them pretty cheap from one of many board houses. If you don't want to wait a month or a couple of weeks, you can make a board at home. This is not something I'm going to talk today, just I want to mention it that you can do it. There are two best known techniques of making PC boards at home. One is using toner transfer, another is using photoresist. I use toner transfer, and you can get, after a little bit of practice, you can get very good boards. Even I made the one board for 0.5mm SMD chip, and it worked. So my preferred technique is to make a board, cover it with flux, transfer solder to the pads, again cover with flux, place components, and reflow it. It's very, very quick. No matter how many pins you have on the board, you may have several chips with hundreds of pins. It makes no difference because you don't deal with each pin separately. You reflow the board pretty much entire board at once. Well, this technique is very simple, does not require expensive tools, however has limitations. The problems that I found that I had was with bigger chips which have heatsink underneath. Sometimes manufacturers call it heat slug. So this is pretty much a piece of metal at the bottom of the chip which you solder to the board. This can be very tricky because if you apply too much solder under the chip, the chip will float on it. I had a very similar problem with USB 3, micro USB 3 connector. I applied too much solder under the frame, and it lifted the connector, and the pins didn't make good contact. So this is tricky. This can be difficult. Another problem that I found is that it's quite difficult to apply enough solder to small solder pads. So anything smaller than 604 can be tricky. But on the other hand, I don't think there will be many people working with smaller components than that at home. So what are the tools that you need to have to work efficiently with SMD components? First of all, soldering iron. This is no-brainer. What is a no-brainer is what tip to use. As I said, don't listen to those people who recommend you to get thin tip, very thin tip, because it's not useful. Get good chisel or conical tip, but regular size. Another tool that you should use is hot air station. This puppy. Pretty much any hot air station designed for SMD work should be fine. You can get a big station like this one. There are smaller stations, there are pretty small stations which pretty much, where everything fits in the handle. So in the handle you have heater, you have blower, you have pretty much everything. I don't know how well they work, I never worked with them, but I know that people use them. Another two things that you should have is flux and solder. Solder, just use regular solder. I use this one. This is from Radio Shack. I think this is 1 millimeter or something, or a little bit less. Don't get. It's unnecessary to get very thin solder. You will not use it.
Jason,
yes.
Define radio solder. You're talking about lead tin, right? Not the lead.
I'm using lead tin. You can use without lead. It doesn't matter.
Are you using lead-free?
Not this one. I still have quite a lot of the solder on the spool, so I don't think I'm going to change anytime soon. But I'm not a fan of lead-free solder. Let's say that. It's okay. Let's not go into this. I use leaded solder. So what is my procedure in general? Apply flux to the pads, solder the pads, transfer the solder to the pads. After then you can clean the board. It's recommended, but it's not crucial. I almost never do it. Apply flux again. And I cannot stress enough how important this step is, because this will determine how well your components will reflow. Then place the components, reflow, clean the board. So let's start with flux. I like resin-based flux. I got it in such pen. It's pretty convenient to use, small, pretty cheap. It costs like a few dollars. And this is, MG Chemicals 835. This is exactly this one. I have another one, Kester 951. I got it because many people recommend it. Don't buy it. It's not a bad flux. It will Probably it is very good when you work with BGAs. Many people who actually those people who fix broken Xboxes recommend this flags, but for me, it has too short board life. What does it mean? It evaporates very quickly. So after 10 seconds, you have no flags. So it's useless. Another flags that people recommend is Kester 186. I don't have any experience with it, but from what I read, it's a pretty good compromise between activity and residues. Another thing that you may want to look at is whether this flags is clean or no clean. The resin-based is definitely, you have to clean. The other ones are no clean, however, it's still recommended to clean after that. Placing the components. The simplest tool that you can use are tweezers. These are with bent tip, very good for placing components. Can be a little bit tricky when you get flags on the tips, because the components will stick and it will be pretty difficult to place them, but well, just clean it. Another tool that you can use, and which is also pretty convenient, is vacuum pick. You will find on eBay lots of such picks, manual, that you have your needle here, you press the button, touch the component, release the button, it sucks the air and holds the component. That's the theory. It doesn't work. Don't waste money on it. Try to find something like this. I paid $15 for this. So you can find pretty cheap. What is this? It's small vacuum pump. You have this is your handle, and it has a small hole here in the metal part. So it works this way that you install needle on this, you touch the component with the needle, and as long as this hole is uncovered, it does nothing. But the moment you close the hole, it starts to suck the air through here, and it sucks the component. You can carry it, place on the board, open the hole again, the component is free. This needle, raw needle without any caps, is good for smallish components. For example, 0805 works well. For smaller components, you should have a cap.
So you need several sizes.
Yeah. So, you don't see it. Yes, these are the caps. Let me take them out. Can everybody see? Different sizes of the caps, tiny. This tiny is good for small components. This big one is good for QFP chips, bigger chips. And you mount it on the needle like this.
Move
raise your hand.
Oh, okay.
There you go.
It's trying to keep it focused, it's the problem. Can't get too close.
Yes, good.
All right?
So it's like an earbud.
Yeah.
Deal back.
You can get needles, you can get these caps on eBay, they are pretty cheap. So let me show how it looks on the handle.
That's good enough.
Yeah. And this is the hole that I talked about here. Yeah.
Look at you. Okay.
Yeah, watch where you're, you got a dark background, move it up.
Don't look.
I'm gonna get a contrast. There you go.
Is it better?
You're okay there. We see it. We see it.
Right. Okay, let's go with presentation. This is okay. And this is why I really like the resin floats, because it acts as a glue. Once it dries a little bit, it's sticky, you can place the components, they will not go anywhere. You can shake the boards, it will hold them. Next step is reflowing. Hot air. Use hot air. This is all you need in most cases. What you should pay attention to is the airspeed and temperature. And there's not a rule what you should set. For small components, you should be careful not to blow the components of the board, because if you blow too hard, they will just fly away. Temperature, if you set too low, it will not melt the solder, or will heat up the board too slow, and you may burn your components if you do too slowly. If you set too high, you will burn the board and components. On the other hand, if you have board with lots of copper, big components, you should set higher airflow and bigger temperature, because that's when the heat transfer is better. To reflow the solder, you have to heat up both the board and the components. As I said, with big boards, heavy components, also with components with. May I get some water, please? May I get some water, please? Water. You will have to heat the board for a long time, and you risk that you will burn the board or components. This is where something called board preheater helps a lot. This is such device. This is board preheater. You can set the temperature here to which it will heat up. However, don't trust this temperature display too much, because it measures temperature here at the heating element, not on the board. Get small thermocouple. Most of universal meters have temperature meters, and use this to measure the temperature. This is infrared preheater, so it has heating element here. Another kind of preheaters is uses hot air. So thank you very much. Another type of preheaters uses hot air, which blows from the bottom on the board, but I'm not sure how good it is. I prefer this one, so I got this one. Something like this. This was about $100 shipped.
Sorry, say 100 or 600?
100. You should preheat the board to about 160, 170 Celsius degrees. Does it look? It looks a little bit high, but actually it's not. You have to heat the board enough to actually start. The solder will start melting soon, but it doesn't melt yet. If you do it in reasonable time, let's say in like 10 minutes, don't worry about frying the components. Why? This is the industry standard temperature profile for retro soldering. And what you're doing with the preheater, you're like mimicking this curve. So first you preheat the board, and this is recommended that for lead-free solder is to up to 200 Celsius degrees. For lead solder, it should be like 175. My recommendation is to heat a little bit less, so you can keep the board longer on the preheater. And then, because you preheat here up to this point, you can blow the hot air from the hot air gun only just for a few seconds. That's enough. Otherwise, you would have to spend like a minute, half a minute on heating up the board. And this is much more dangerous. And you can actually fry the components. It happened to me. I was soldering this board. Yeah, well, don't worry, I should have a picture of the board. I was soldering this board, and here I have tiny dip switches. Two of them did not solder well. I have to rework them. I didn't feel like placing the board on the preheater again, and I fried them. One I have to throw away, another one still works. But well, instead of saving time, saving effort, actually it's made me do the work twice. So it really helps.
Is the curve the same for, your dad says lead-free, is the curve the same for regular solder that you're using?
The temperatures are a bit lower. For lead solder, I believe this plateau is about 175 degrees. Also, the top temperature is a little bit lower. However, the shape is pretty much similar. I believe this one is for lead solder. So these are the stages that you have in soldering. So first, and this is designed for using solder paste, so it does not exactly apply to soldering when you just transfer solder to the pots. But the shape, you can keep the shape. Next stage is cleaning the board. I told you that this is very difficult. It's not difficult. Very important. Why? Well, the resin, you have clean and no clean fluxes. You don't have to clean the board if you use the non-clean. If you use resin-based, you will have thin layer of resin on the board. It's after reflowing, it's not sticky anymore. It will not collect dust. However, I learned the hard way that it's very important to clean even the reflowed hard resin. I was replacing USB 3 connector on one board because it broke, and I didn't bother to clean the residues too well. I just wiped it a little bit, and it seemed to work fine. But at some point, I started to get random problems with USB 3. It worked fine with USB 2, and I couldn't find out what it was. I talked with software people. They had no idea what was happening. I was debugging. For several days, I was going pretty much down to the single lines of code. I couldn't find nothing. Turned out that there was small residue left on the high-speed USB 3 pins on the connector, and it was pretty much destroying signal integrity for the high-speed signals. After cleaning well the board, cleaning well the connectors, the problems disappeared. How to clean the board? Very simple. Go to CVS, spend $1 on such complicated device, get a bottle of isopropyl alcohol, that's it. What I do, I go through several stages, through 3 stages. First, I use the brush to clean the resin, the flux. I just brush the board. I do it until I don't see any more resin, flux on the board. Then I wash the board with water. Distilled water would be best. I just use tap water. Don't soak the board, just rinse it. Just run it through the water, that's it. This removes the dirty alcohol from the board. And then again, I rinse the board with clean isopropyl alcohol. This removes the water from the board. Yes?
My experience is when you go and buy isopropyl alcohol, there's a lot of water in it, and we found if you use anything less than the 70% isopropyl, or 30%, they use so much water in your board because it's already there.
Yes, but the reason why I use water is to wash off this dirty alcohol. So you may do it, you don't have to figure out yourself. I like to wash it with water. And then after you clean with clean isopropyl, you will have very clean, dry with paper towels, let the leftovers evaporate, and you will have clean board without smudges, without traces of the flux. So how to do it? I prepared a small short clip from YouTube video, which will show you how to do it. I hope it works. Yeah, it works. So this is the first stage. Apply flux to the solder pads and transfer with the soldering iron. Transfer the solder on the board, on the pads. So you can see that after he went through the pads, there are blobs of solder on the board.
So are you putting the solder on the tip of the iron and then transferring
Yes,
it to the
yes,
tip
yes,
of the iron? Okay.
exactly. And this is the heat pad under the chip. Now clean the board, apply flux again. This is probably one of the most important steps during the entire process. Fluxing before placing the components.
Jess, if you move back just a little bit, you can't see.
Sorry. He is removing excess of the solder. Yeah, this is the fluxing. Place the component. It will stick to the flux. It will hold well. and reflow it.
Apologies for interrupting, but a very nice thing to be helpful is if you accidentally do a gong, that gas iron will be very effective in taking the part off and you can do it again. Gas irons are helpful in that way.
Still, I prefer hot air station.
Not assuming that's on the option. Not assuming that's, I mean, hot air station.
Yes.
Self, we're getting it off.
Yeah, and you see that, yeah, one more thing. You don't have to place the component exactly over the pass. If you just aim a little bit, well, it cannot be one off.
Close enough, it's
It'll
perfect.
pull it back in.
Yeah,
It centers itself.
yeah, it centers itself, the surface tension will pull the part in place. And this is the final result. QFN chip, tiny, soldered perfectly. The tricky part is to know how much solder to apply, especially to the center part. You just have to figure it out. You have to try several times until you know how much to put. You put too much, and it will float on the solder. It will not get to the pads, to the board. You put too much, it will not hold. The heat transfer will be insufficient. There's another very effective technique when you work with integrated circuits which have pins on the side, like for example, these chips here, they have pins on the side. You can use another technique for that. And this is called drag soldering. You pretty much make a big ball of solder on the tip of the soldering iron and you drag it over the pins. That's it. And now, you don't have to worry about bridges if you do it quickly, if you know how to do it, if you don't drag the tip over the pins. Usually you don't get the bridges. But you have to practice, but even if you make bridges, this is just use solder wick and you will quickly remove them. You can use it with regular tip, again, not the thin soldering tip, just regular everyday tip, but there are special tips for working with it. This is called mini wave, and what is special about this tip? It has a small dip here. This is like a reservoir for molten solder. So you put solder here, make like a nice droplet on this, and drag it over the pins. I wonder if it. Oh, yeah. And this is actually me soldering the chips on the board. So you see, I have the mini wave tip. I drag over the pins. That's it. It's soldered.
Came out beautifully though. That's a working word.
Done. Few seconds, entire chip is soldered.
What was the tip temperature? 280?
290 or 300 Celsius degrees.
That exceeds public.
Yeah, I know it's a little bit hot, but it works well.
Okay.
Was the board preheated for that?
No, not for the drag soldering. For reflowing, yes. For drag soldering, no.
So the pads were just flaps, they weren't pre-soldered?
Yes. So I applied flux here. That's it.
That's the advantage of the wave solder.
Yeah. Well, you have flux in the solder, but once you put it on the tip, you don't have the flux anymore. So you have to apply before soldering.
Flux is your friend.
Exactly.
In the right place.
Exactly. Can you do better? Yes. So as I mentioned, this technique is not very effective for soldering very small components. It is difficult to apply the right amount of solder to the parts. You may blow the components of the board. Some people have luck with soldering small BGA chips on the boards with hot air. However, it's a pain. Yeah, the problem with applying thin layer of the solder, put too much and you will have problems. What you can do, switch to applying solder paste. So this is what everybody in the industry does. You can do it at home, trust me. It's not that difficult. You can do it at home two ways. One is get solder paste in a syringe. You can get it for a few bucks on eBay, and then just squeeze the solder paste on the board, on the pads from the syringe, using just squeezing by hand. It's very hard, it's very difficult. You can get something like this. It's a solder paste applicator. This is how it looks. So here you connect compressor. Car tire compressor works well. Just get some small plastic bottle as a reservoir to just have some. Well, the air from the compressor is pretty choppy, so it's you will smooth it out. And here you connect hose which goes to the syringe. In the syringe you have it pushes the how do you call it? Spark which?
Component.
Yeah, plunger. It pushes the plunger, and here you can set pressure, how hard it should push. Here you can set for how long it should be, so you can pulse it. And another thing which is not obvious, after it switches off, it sucks the air. Air is compressible, and once you push the air, it will take a while until the pressure dissipates. So this device actually, just right after it switches off the pressure, it sucks the air. So you know exactly, you can control very precisely how much the plunger goes. Such devices, new on eBay, sell for about $100. Unless you find someone who doesn't know what he's selling, I bought it for 25 bucks.
Same applies at Hamfest sometimes.
Exactly. Another way to apply solder paste is to use stencils. This is what everybody in the industry does. Good industrial stencils, they are made of stainless steel, and it's pretty expensive, but you can get for a few bucks cheap stencils made of plastic. Many board houses will make a stencil for you when you order the board. It costs, I think, $20 more. It's cheap, it's not very good, but good enough to make like 3-5 boards. How to do it? I will not show it. Go to YouTube. There are plenty of videos which show how to apply the solder paste. if you don't want to pay someone to make the stencil, you can get a CNC cutter from craft store and you can cut it yourself. People do it. It also works pretty well. It's not that good quality as laser cut, but also works. Another tool that you can get pretty cheaply is your own reflow oven. You can get reflow ovens from Chinese manufacturers for like, I don't know, $300, $500, $800. This is pretty cheap. People buy it. They are not very good quality, but you can do it much cheaper. What people do, they go to the store and get just a toaster oven. You can find on the net, and this emulates industrial process of reflowing. First, you can get a controller which will control the heaters. It will make sure that you follow the nice temperature profile. It will preheat the board to soaking, that it will keep the temperature constant for time, then will heat up for reflowing, and then you have to open the door for cooling. But if you want to start, it's very simple. Go to the store, buy the nicest toaster oven that you can find, bring it home, give it to your wife, take her out toaster oven.
Or get one at a garage sale.
You can, but your wife will much more appreciate if you get in one. And you're set.
You do the pizza and then afterwards?
Depends on what you like. I prefer to keep lead away from my pizza. But you can add an extra spice, it's up to you. What toaster oven to get for reflowing? Well, most people use the cheapest ones with just one heater at the top, one at the bottom. It works well if you don't have very big boards. It's mostly the angle between the heater and the board. Keep in mind that this works using infrared radiation. So the angle at which the radiation falls actually makes a huge difference. If it is up to like 30 degrees, it's okay. If the board should go here, so the angle would be like 45 degrees, I think it's better go with more than one heater. Yes?
How about one of the convection ovens that they have out there?
Convection.
Convection novel. Moving air. Instead of the
May work. I never saw anybody that was crazy enough to buy such an expensive oven to use it. But it should help. But it's mostly the infrared radiation, so I'm not sure if it will help much.
Well, infrared gives you better time control over the
Yes.
temperature. Do you get,
You switch off and it immediately stops heating. You can build or you can buy a controller which keeps track of the temperature, but for the beginning you can get just by small thermocouple, hook it to your meter so you have temperature control, take a stopwatch, look at the temperature at the stopwatch, at the temperature profile, and just try to manually control it. That's it. That's good for the beginning.
does that work on heat sinks? When you have heat sinks on the components, can you heat them properly that way with
Yeah, it should
radiation?
work.
So you're heating it right through the component?
Yes. Oh. Okay, so this is the typical setup. How much time do I have?
He's got,
Hey, how
how
long
much
is
time does he have?
Okay, can you spot a problem with this board?
5 minutes.
5 minutes.
Some rounds in there.
Forgot to put components on. Just 3 volts.
This vias here. They were not, this is not a mistake, I did it by purpose. I wanted to see how it worked, what will be the problem if I can work around this problem, but I will tell you in a minute what is the problem. Few words about designing boards. Designing boards for SMD is easier than for through-hole. You have more space to route signals. Always, when you order the board, always order solder mask. It helps to prevent forming bridges. Avoid placing vias under components. This is what I did here. This vias will suck the solder from under the component. So this is for big voltage regulator. It is soldered here. It very efficiently, those vias very efficiently suck all the solder from under the component. If you have to place vias, check the data sheet. Usually manufacturers tell you how big they should be to not to suck the solder. Tip for drag soldering: you can get, even if you're skilled, you can always get solder bridges at the end. This is because the solder just sticks to the last 2-3 pins. The industry method for dealing with this, for wave soldering, is to place something what is called solder teeth. This is a bigger via, a bigger pad at the end of the chip, and this is board manufactured by industrial manufacturer, and it was soldered on a solder wave. So the wave was going this way. This was the last pin to go of the wave, and the solder did not stick to these pins here, did not make the bridge, stuck to this pin here. Okay, that's it for the presentation. Do we have time for practical part?
We could schedule you next time.
Okay.
Yeah.